Okay, welcome in fact lecture. Till date, we have discussed the variable impedance type series compensation, or the series compensators are there, and in which there are three type of compensator method has been discussed. One is the gear turn off thyristor control series capacitor. Second is the thyristor switch series capacitor, and third is thyristor control series capacitor. Now the second subcategory of to obtain the variable voltage or control over the series compensation is the switching converter type series compensator. And in there is one method that is called as a static synchronous compensator, SSC. SSC is a series reactive compensation as per the definition of IEEE and SIGRE. That is, as the definition of this one is definition as per IEEE and SIGRE, CIGRE. Okay, so IEEE is the Institution of Electrical and Electronics Engineering, whereas the English name of CIGRE is the International Council for Large Electrical Power System, or large electric system is there. Okay, so as per this one, SSC is the series compensator. SSC is the series reactive compensation scheme using a switching power converters as a synchronous source, synchronous voltage source to produce a controllable voltage in quadrature with line current. So it is, what is the SSC, or static synchronous series compensator? It is a series reactive compensation using switching power converters as a synchronous voltage source. So we are using power converters. We are not using over there is a reactance or capacitive reactance or inductive reactance, whereas we are using a power converter as a synchronous voltage source, SVC, to produce the controllable voltage which is in quadrature with the line. This is very important. Whatever the voltage is there, it is in quadrature with the line current. So what is the SVC? SVC is the static voltage source converter. SVC is the static voltage source converters, which produces a set of it produces a set of three-phase variable voltage by static electronic circuit. Therefore, it is called as a static voltage source converter. Now, it is a source of voltage. Therefore, it is connected. It may be connected to inject the voltage in series with the transmission line. So, what would be this? The diagram. Say it would be like that. Say this is the line current, or this is the transmission line, and with the help of static voltage source converter, there is some transformer or a coupling transformer, injection transformer, and with the help of voltage source converter SVC, it is possible to inject the voltage in quadrature with the line current, and this is nothing but the SVC. Okay, so it is going to inject the voltage which is in quadrature with the line current. This is the line current, and this is the voltage. Say it is a VC or it may be a VQ as per this one. Okay. So the schematic diagram of the voltage source converter along with the some control parameters is like that. So this is the transmission line. Transmission line. So line current, transmission line current I, and there is a coupling transformer or injection transformer. It is connected with the SVC, static voltage source converter. Static voltage source converter. So this is the SVC, static voltage source converter, and it can be controlled by some control circuit. The control, and there is a two parameters. The reference parameter. It may be a say Q reference, a reactive power reference, and it is a active power reference. This is the some reactive power, and with the help of this static voltage source converter, it produces the AC voltage, variable voltage AC. Okay, and this AC voltage is connected to the coupling transformer. Coupling transformer, and with the help of coupling transformer or injection transformer, a control voltage can be injected in the transmission line. Definitely, this transmission line, the injected voltage should be in quadrature with the line current. Now, this SVC is connected with a small DC voltage source or capacitor. So this is some DC power. Okay, so it is a DC power which is going to generate the DC small amount of voltage, and there may be or it is optional. There may be some storage devices. This storage devices or storage system may be a superconductor, supercapacitor, or some battery system which is used to inject or absorb the active power. So it is an energy storage. Storage that is optional. It is not for the reactive power compensation. Our aim to give the reactive power consumption. This one, reactive, series reactive compensation. And therefore, this energy storage is the optional one. Now, when it is injecting the voltage in quadrature with the line current, definitely there is a flow of reactive power, and this flow of reactive power is in both sides. this reactive power, it is in both sides, so it can be represented as a Q. It means that when the reference active reference P reference is equal to 0, it is going to interact, or it is going to deliver or consume, means generate or consume only the reactive power, that is the reactive compensation, the capacity, the reactive compensation. And whereas reference P reference also going to change with connection of the energy storage system. This is related with the energy storage system. Definitely there is a interaction, or there is a flow of active power. Either it is going to consume, or either it is going to deliver the reactive power, this P. So when there is no reactive power, there is no active power, say, flow between the SVC and the transmission line, P reference is equal to P reference, we kept is equal to 0. Only the reactive compensations are there. Now, why we are calling as a reactive compensation? With the help of SVC and control circuit, it is possible either to inject the voltage which is in quadrature, maybe a lagging side or maybe a leading side. So it means that, suppose this is the current I, transmission line current I. If the injected voltage, say this injected voltage is equal to VQ, as it is in quadrature, so we will give the name as a VQ. If this VQ is lagging by 90 degrees with respect to the current, it means that the current is leading one. The current is leading one, is the anti-clockwise direction. It means that it is a capacitive. The reactive compensation is the capacitive reactive compensation. It is a captive. And whereas when VQ is leading with respect to the current I, it means that VQ is leading, or we can say that the current is lagging, and therefore it is called as a inductive reactive compensation. So in this side, it is a inductive side, and it is a capacitive side. So what is the advantage? The advantage is that with the help of a switching converter type series compensation, that is called as a static synchronous series compensator, it serves to inject the capacitive reactive power as well as the inductive reactive power. And if the energy storage system is associated, or it is connected with the SVC, then it is also going to deliver or consume the active power. So it is just like a StatCom, which we have already discussed in the shunt compensation. Now, what is the analogy, or what is the similarity between the series compensation which we have studied till date? So it is just similar. Say this is the voltage, sending end voltage is Vs. Now we are connecting a capacitor in series with the transmission line. This is the transmission line reactance, and this is the receiving end, Vr. It is a two-machine system. It is analogous to the two-machine system. Now this is the value is equal to XL. This is XC, JXC, this is JXL. So under such condition, the voltage are shown as per this one. It is a VC, and it is the VL, and power is equal to, which we have studies, V square divided by XL minus XC into sine delta, isn't it? And whereas without any compensation, power P is equal to V square upon XL into sine delta. This is uncompensated line. Uncompensated. Now, this representation is for the reactive compensation. But what we are doing? We are going to inject the voltage. So instead of this one, means it is replaced this circuit can be replaced for our understanding purpose. This circuit is like that. This is the voltage source, static voltage source converter, and this is the transmission line reactance as it is. And again, this is representation of the two machine system. So this is Vs. This voltage is Vq, which is in the quadrature. It is in the quadrature. This is the line current I. This is reactance XL, and this is receiving end voltage VR. So it is two machine system. So it can be represented as this is voltage Vs, this is VR, Vs, VR, okay, and this is the voltage VL, this is the current VQ, this is the voltage VQ, okay. So under such condition, we can write what is VQ? It is VQ is equal to minus J I into minus J I into XC, isn't it? So we can write as which is equal to minus J into I K into XL or X, isn't it? What is K? K is the series degree of series compensation, XC upon X. Okay. So in this way, VQ, the voltage injected in the transmission line, which is in quadrature with the line current, it may be lagging by 90 degree with respect to the current, or it may be leading by 90 degree with respect to the line current. So the power P is equal to V square upon XL minus VQ upon I into sine delta. Now this equation for the capacitive compensation, capacitive series compensation. Isn't it? Whereas if this is plus, it means that the current is lagging by 90 degree with respect to the VQ, and it is for the series compensation. So this can be represented as, or VQ in the generalized equation, VQ is equal to plus or minus J VQ with the function of zeta, it is the operating parameters, into I upon I dash upon I. So it is an independent, so the voltage injected by the say SSC is independent of the line current. So this is the major advantage. What is the major advantage? The injected voltage VQ is independent of line current. So earlier, which it may be a TC-SC, or it may be a thyristor switch series capacitor, the compensation is depend upon the line current, because we are going to compensate with the help of reactance. Whereas the injected voltage is independent, because it is going to generate with the help of a voltage source converter, static voltage source converter. Therefore, the voltage source converter output is independent of line current. So it is a major this one. Okay. So when VQ, we can say that VQ lags behind 90 degree, behind current I by 90 degree, okay, then it is called as a capacitive compensation. It is a capacitive compensation. Whereas when VQ leads by current I is a 90 degree, okay, then it is a inductive compensation. So one may write, say this is the equation which we have written, it is for the capacitive compensation, or we can write P is equal to V square upon XL plus VQ by I into sine delta. It is for the inductive compensation. Okay, and what is the injected voltage VQ? So where the parameter zeta, it is the control parameter, and the value of VQ as the function of control parameter, the range is equal to, say it is 0 greater than equal to VQ, the function of control parameter is VQ maximum. So this is the range of voltage by which we can control the reactive power, reactive voltage compensation in the transmission line. So this is something which is related to the static compensation, static series compensation. That is a voltage source, static voltage source compensation over this. Thank you.